All right, today what we're going to be talking about is we're going to be talking about dimensional analysis. Sometimes you'll hear me talk about it as the factor label method. Another one that people talked about was they've used the word nert-nerts, and I'll show you what nert-nerts is or why it got that name and so forth. And it kind of comes from one of the things that we do when we go ahead and set up this dimensional analysis. Basically, dimensional analysis, it's really going to be converting between units, going from one quantity or one set of units to a different set of units. Dimensional analysis is a method of converting from one unit to another unit, and it is done by using the SI prefixes that are found on page 26. Again, talking about milli being 10 to the negative third, talking about micro being 10 to the negative sixth, those ones that I told you that you're going to have to know. Again, the sooner you know these, the easier it's going to end up being, because like I said, we're going to have some quizzes. The test is going to have lots of conversions on it, but like I said, the sooner you get to know these, the easier it's going to be. Some of the rules. Okay. Number one, start off with your given. Okay. So when you're setting up this factor label method or this dimensional analysis, make sure you always start off with your given. Number two, using each prefix or exponent, determine the distance between them. Okay. And again, I'll go through, but treat it like a number line. So if you have a 10 to the sixth and a 10 to the negative 3, how many spaces are between them? Okay. For example, if you have a kilo and a micro. So when I look here, again, micro is 10 to the negative sixth. Kilo is 10 to the third. Again, if you go ahead and think about this, really what you'd have is you'd probably have kind of 0 located right in there. So again, going all the way from here and traveling all the way over here to the 3, there's a distance of 9 units. Okay, and that's going to be important when we set up our factor label method or our dimensional analysis. Okay, so between a negative 6 and 3, or between micro and kilo, is going to be 9 units. And again, what I did by that, and just letting you know, again, I used the exponents. Okay, so kilo is 10 to the third, and what we have here is 10 to the negative sixth. That's micro. So I'm using the exponents to set up this number line. Number 3, we're going to place a 1 with the larger of the two prefixes. Okay, so again, when I'm looking at kilo and micro, kilo is higher on that chart, or kilo is a bigger prefix. So when I do my dimensional analysis, the kilo or the prefix kilo is going to get the 1. Number 4, the number you found in number 2 becomes the exponent on the power of 10 that goes with the smaller of the two units, or the smaller of the two prefixes. And the other thing that I want to stress about this 9 units that we're talking about, when I go ahead and I come down here in number 4, that 9 is really going to be a 10 to the 9th. Okay? And the other thing is, you will only have positive exponents. We are positive in science. We're never going to be negative individuals. Okay? So that distance that we find on that number line, it's going to be used in the exponents in number 4, but it's always going to be a positive value that we end up using. Any numbers that are located on top, we multiply, and any numbers that are located on the bottom, we're going to end up dividing those. So let's go ahead and look at an example. First one we're going to do is we're going to take 1.3 times 10 to the 4th gigagrams, and we're going to go ahead and convert it to grams. G is giga, but the other one doesn't have a prefix. Again, when you look out here, okay, there's giga, the G means grams, the G means grams, but when I look there, there's nothing there. And if you don't have a prefix, it's considered a base, or 10 to the 0. Okay, so when we set up our number line, when we use that other prefix, we'll use gigas exponent, but the other one, we're just going to use 10 to the 0. Okay, so setting up that number line. The 0, there's my base. Giga, there's my 9. So obviously the distance between them is going to be 9. So here's my nert. And basically what people say is, okay, so you draw your line going across, and then you draw your line down, so it's kind of a nert. Okay, so a nert. So we go ahead and we start off with our given. Okay, so we're going to take our 1.3 times 10 to the fourth and we're going to place it there. Now, again, if you remember what I said, the larger of the two prefixes, giga is a bigger prefix than the base of grams, so it's going to get the 1. That distance, that timeline that we talked about, 0 to 9, there's 9 units. 1 times 10 to the 9th is going to go on top. Now, the reason why we set it up this way is anytime you have things in math where they are opposite, they're going to cancel each other. And that's going to be important in setting your factor label or your dimensional analysis up. You want to make sure that you have your given on top, so gigagrams, and to get it to cancel out, we've always got to put our gigagrams down on the bottom. So your units will always be opposite that we want to cancel out. The one that we're going to is going to be on top. Now, when you look at these two numbers are on top, so we're going to multiply all numbers on top. So we're going to take 1.3 times 10 to the fourth. We're going to multiply it by 1 times 10 to the ninth. We divide it by the numbers on the bottom. The number on the bottom is only a 1. Okay, so that's no big deal. And when I do that, I'm going to get an answer of 1.3 times 10 to the 13th. Okay, let's go ahead and look at one that has a couple of prefixes. We've got 74 nanograms, and we're going to convert it to, notice this is a big M, so that's megagrams. Okay, first thing that we're going to do is we're going to set up our number line. Here's our nano, 10 to the negative 9th. Over here we've got our mega, that's 10 to the 6th. So going from negative 9, 0 will probably be somewhere in there, so there's 9 units. We're going to go from 0 over here now to 6, so that's 6 more units. So what we're going to do is we're going to have a distance of 15. And I went ahead and I wanted to write this one out. Again, mega's your bigger prefix. So what we're saying is 1 megagram, the bigger prefix, is equal to 1 times 10 to the 15th nanograms. And that's your smaller prefix. Again, we said the bigger of the two prefixes gets the 1. The smaller of the two prefixes gets that positive power of 10, with that distance being the exponent, that 15. Setting up our NERT, or our dimensional analysis. Again, remember what I said. We're going to take our given, and we're going to move it down there. Now, again, 74 nanograms. Now, you're going to see it on the next slide, or when I hit it. But again, what we want to do is we want to put the nanograms there so they're opposite where they're going to cancel out. We're going to put the megagrams up here. And then what we do is we look at what we just said. 1, it's going to go there. The nanograms is going to go on the bottom. Okay, so filling those numbers in are given 74 nanograms. The 1 times 10 to the 15th nanograms there, 1 megagram there. Okay, multiply the numbers on top. So we're going to take 74 times 1. Okay, divide it by the numbers on the bottom. And what you'll do is you'll get an answer of 7.4 times 10 to the negative 14th megagrams. Okay, let's look at one that has a couple of units. So what we're going to be doing is we're going to be converting from kilometers to millimeters, and we're going to be converting from hours to minutes. Okay, the first thing that we're going to do, and this one I'm actually going to let you see me or watch me kind of draw it up, but the first thing we're going to do is we're going to figure out our timeline or our number line. Okay, so we've got milli. Milli, the exponent is a negative 3, or 10 to the negative 3. Kilo, we've got kilo, that's going to be 10 to the 3rd. Okay, so the distance between them. The distance between them is 6. Again, when I look at my prefixes, kilo is bigger, so it's going to get the 1. The bigger of the two prefixes gets a 1. The smaller of the two prefixes always gets the positive power of 10. So the 1 times 10 to the 6th. Let's look at our other conversion here. We're going from hours to minutes. I'm hoping you all remember that 1 hour is 60 minutes. So we can go ahead and start setting up our NERT. We've got 34.5 kilometers. Now notice it's kilometers per hour. So I'm going to set it up like this. Kilometers on top, hours on the bottom. So first thing I want to do is I want to get rid of my kilometers. And remember, to get rid of something, they got to go opposite of one another. We're converting from kilometers to millimeters. So we're going to go ahead and fill in. Kilometer is the bigger of the two. So millimeters is going to get the 1 times 10 to the 6th. So my kilometers cancel. Now if I were to stop right here, I would be in units of millimeters per hour. But I want to go millimeters per minute. Now, notice where your hours is. Your hours is on the bottom. And we said for something to cancel out, they have to be opposites. So if hour is on the bottom, to get it to cancel out, we're going to put it now on top. And we're going to put the minutes on the bottom. We're going to put 1 hour there. We're going to put our 60 minutes down there. My hours will cancel my hours. So the only units I have left are a millimeter per minute. I'm going to go ahead and multiply everything on top. So we're going to take 34.5 times 1 times 10 to the 6th. 60 is on the bottom, so now we're going to divide it by 60. 575,000 millimeters per minute. Final answer, 575,000 millimeters per minute. Now our last one. This is going to be when we're working with areas, or this is going to be when we're working with volumes. See, the thing is, the past problems, or the past 3 problems or examples that I've given you, that's just been straight out in one dimension. Okay, we're looking at a simple length, or we're looking at a simple time. But when you look here, we're looking at a kilometer squared, and we're looking at a centimeter squared. So really everything else kind of stays the same. We just have one little step that we need to add to it. Okay, so let's go ahead and let's look at it. Everything else is going to stay the same, or the first part will stay the same. So we've got centi. Centi is 10 to the negative 2. Kilo is going to be 10 to the 3rd. Set up our little number line, and you're going to find out the distance between it is 5. But what we're saying is 1 kilometer, by what we just did, 1 kilometer is equal to 1 times 10 to the 5th centimeters. But the thing is, we don't want kilometers and we don't want centimeters. What we want is we want kilometers squared and we want centimeters squared. What we need to do to get kilometers squared is we need to go ahead and square that. Now math says what you do to one side, you have to do to the other side. Well, 1 times 1, that's just going to give me 1 kilometer squared. And when I take 1 times 10 to the 5th multiplied by 1 times 10 to the 5th, what you get is you get 1 times 10 to the 10th centimeters squared. Now, the best way to do this so you get your exponents correct is take these numbers right here and multiply them. Okay, so 5 times 2. And that's going to give me 1 times 10 to the 10th centimeters squared. So anytime you have these squareds up here. Again, all of the other problems, when you think back, we were doing gigagrams and grams. We were doing nanograms and megagrams. We were doing kilometers per hour to millimeters per minute. Now we're looking at a squared. And so we have to do that extra step before we go to the dimensional analysis. Once we have our kilometers squared and our centimeters squared, we can go to our dimensional analysis. So we're going to go ahead and take our given, 6.8 kilometers squared, setting it up. Okay, so we want the kilometers squared to cancel, so we're going to go ahead and put it on the bottom. We're going to put our centimeters squared on top, filling in. So this is going to go here. So 1 times 10 to the 10th centimeters squared. Our kilometer squared is going to go down here, so 1 kilometer squared there. So we're going to go ahead and now multiply. Okay, kilometer squared end up canceling. Multiply 6.8 times 1 times 10 to the 10th. Okay, we're going to divide that by 1. So you're going to get a final answer of 6.8 times 10 to the 10th centimeters squared.